within the 360 degree, right? So the coterminal will be the right answer. So let me solve this problem most general way, not just the way I know how to solve this. We're going to just think about rotation and by fiddling around a little bit, and you can answer that problem. But I'll approach it a little bit better so that you can answer this problem if it is 8,000 degree, not 800 degree, right? So here is solution. Let me fix this problem, solve the problem. All right, angle we are looking at is beta, I'm going to call. That's 800 degree in standard position. They don't say anything, we're going to say a standard position, right? And we are looking for theta, they call theta, so alpha is going to change the theta, right? So here's beta. Theta, they're not equal to each other, right? But what's the relationship? Remember the formula? Beta and theta is not equal to each other. How much are we going more? 360 times n degree, right? So we're looking for that n in there. So let me just work with the magnitude and drop this degree. So that means 800 is equal to this unknown angle theta plus 360 times this unknown integer n. That's what we're looking for. Okay? 800 is given. You want to figure out theta and n. Okay? The next thing we can do, we're going to figure out the special thing about n being an integer. You divide both sides by 360. Then 800 divided by 360. And what do we have here? The theta divided by 360, right? Correct? Plus, if you divide this one by 360, do you see that 360 cancels? And then leaving just only n in there. Correct? So, extra thing we know is that this theta is in between 0 and 360 degree, right? If you divide both sides by 360, 360, and 360, that gives us 0 degree theta divided by 360 must be less than between 0 and 1, right? So what that says is that this number in the right hand side, you have an integer plus some positive number which is very small. This part is only showing it after the decimal point. Okay? So I'm going to use a calculator and calculate this 800 divided by 360. So this is a nice method when this is instead 8,000 or 80,000 divided by 360. What do you get? 2.22. So I have 2.22 is approximate. It goes on forever like that, right? That's the left-hand side. And right-hand side is this quantity we don't know, but it is very small. It is less than 1. This is the part of the up to the decimal point. And this is supposed to be integer, right? This is supposed to be integer. So do you see that the left-hand side really breaks to 2 plus 0.22 going forever. And this one theta divided by 360 plus n. That's the integer part, and that's the fractional part. So what should be the correct conclusion? That n must be that integer part, and this must be the fractional part. So you know n equals 2. The 2 rotation is involved. After you knock down a 2 rotation from 800, you will get to an angle that's small enough to fit in 0 to 360. Okay? When you're solving this problem for the test, you don't have to do any of those things. I explained it in the general approach. And at this point, you can just focus on what this, how you get this n value, which is an integer. So what's the bottom line? I divide this angle 800 by 360. That's 2.22, right? And that number came from this integer part 2, right? So he just concluded that that number of rotation involved in the coterminal angle thing is 2. That's the bottom line. But sometimes I emphasize about the method, then you have to reproduce the method. And I usually name that method, and I require that method be shown in the test. So I announce it here. The method I just showed is called so-and-so method. in the test, and I will say, use that so-and-so method. Show me you actually understand the detail of mathematical thinking. This is very basic arithmetic, so you don't have to show that kind of thing in here. But it is an idea if you didn't fully understand why the rotation is involved. Here's a subtle thing. Write interpretation of n equals 2, and this decimal number looking at is not this, turns out this integer part. Right analogy here is that if you have this number written in number line 2.222, right? What is the largest number in the number integer in this number line that is to the left or equal to that number? That number is 2 here, right? That's an integer. That's to the left side or itself, and that's the largest integer that does not exceed 2.22. That turns out to be the correct interpretation. So for example, if I have negative 2.22, right? What is the largest integer that does not exceed this one? Negative 3, right? So your correct choice of n is not negative 2. Turns out to be negative 3. So if you choose negative 3 instead of negative 2, then if you do the rest of the part, it gives you the right answer. Even if you didn't get the right answer, you can fiddle it. At the end, you have very small magnitude. You can add one more 360 if it turns out to be a negative number to get to the right answer. All right? So that's how you get to this n equals 2. What is the correct answer of correct method of finding n equals 2? The largest integer that does not exceed this division, 800 divided by 360. All right? Once you get that correct angle, all you have to do is plug it in there and solve for theta. All right? So the rest of the part. All right, here's 800, right? We don't know theta, but we figured out n, right? What's n? 2. So what's theta? No, not yet. That 800, this is before you divide 360, right? You looked at the divided version. Right? 800 equals theta plus this one. So is that, I forgot the angles there. Is that fair enough? You subtract 360 times 2 from both sides. Any question? I return to this original equation in here. We figure out here n equals 2. I came back to that equation, plug in n equals 2. Theta is the only unknown, so you can solve it algebraically. Yes? This one in here? That one is given in the problem that we started with angle 800. Oh, this side here? Okay, so I switch it around. So maybe if I write it like this, 800, you keep that 800 here and subtract both sides like that, and that's better, right? You're keeping the theta in the right hand side. I switched it around. That confused you. All right? Okay? Then what is theta? What was that? 80 degree? Okay, thank you. If you plug it in the calculator and you get 80 degree. All right? So let's go back to the question and let's see if we answered it. They're looking for angle theta, coterminal, and theta is 8 degree. That's coterminal angle. And the final condition here is the 80 degrees in between 0 and 360. Yes, it's 0 and 360, right? This is a good habit to have. You go back to the problem. You look over the entire thing. Always make sure, does this make sense? Did I answer everything? And this habit will really pay off in the test, all right? Especially for those problems with no partial credit. You have to understand what the problem is asking. Any question? Ready for first exercise? Right. Let's do that thing, 80,000, that degree I'm talking about, right? So, exercise number 1. Ready to challenge it here. Angle beta is a negative 8,000 degree. Find an angle alpha coterminal to that angle beta and such that alpha, the measure of alpha is in between 0 and 360 degree, right? So again, you don't have to repeat that all the analysis. All you have to do is first you divide this 8,000, negative 8,000, right? Negative 8,000, you divide that by 360, and you get a number, and you have to decide which one is correct n value. But it is worth writing this important formula. What formula am I talking about? Coterminal angle formula, right? Let's write that down here. Beta equals what? Alpha plus 360 times n degree, right? So think about how do we compute that n quickly, not slowly like that I did before. How do you compute that n quickly? And you divided it and looked at this number line thing, right? All right, was that okay? All right, I divide that negative 8,000 by 360. Number was negative 22.22. So the number line is here. If you go right up to that point, that gives me the right amount to, subtract off and left with a positive number. So that's the negative 23. So negative 23 plugged into this coterminal angle formula. Then it'll solve for alpha algebraically. Gives you 280 degree. Okay? So 800 degree, you end up at which quadrant is it? 280 degree. Do you know which quadrant is this? First quadrant and second quadrant and third quadrant and fourth quadrant. Right. Third quadrant, the boundary is a 270 degree, right? So it's more than 270. So it's a fourth quadrant is the correct answer. So 8,000 negative 8,000 degrees down there in the fourth quadrant. Any question? All right. Do you think you can do this one for 2 pi thing, radian? The principle is the same, right? Principle is the same. So if I give you 8,000 radian, then what is the angle in radian that is in between 0 and 2 pi? You think you can do that? Right. Reluctant to do so, but I have confidence that you can do that. So beta today at this time is 8,000 nothing. What does that mean? It means radian, right? Beta is 8,000 and it's the angle, and then you assume is radian, right? And find alpha, that is a coterminal, to beta such that alpha is in between what and what? 0 to 2 pi this time, not 360. These are in radian. So use the same principle and write down that coterminal formula first. So I want you to at least do this much, right? State the coterminal formula. Maybe I'm going to do that. To solve this problem, state the coterminal formula and, do the rest of the problem on your own. So if you got the first one correct, give yourself 2 points and record it. Like I said last time, it is up to you if you don't want to share the grades with me, and you don't have to record grading there. But I recommend you to do that. It's good information for yourself. It motivates you a whole lot better if you see the grades for yourself. And that grade is not part of your grade at all. It's just for yourself. Right, so what is the coterminal angle formula? Beta equals alpha plus 2 pi times n. That's the formula. Alright, how was it? Common mistake when you put 2 pi in the denominator, you got to put the parenthesis around it. Other than that, the pi is going to be in the numerator. You're not going to get this 1273.23. Right? Any question? Might you have?
Will you explain how you get this 1200?
1273?
Yeah.
8,000 divided by 2 pi?
Okay.
Yeah. So in the calculator, I will put it like this, parenthesis and 2 pi, like that. Then that gives you correct number. Yes?
So when it's never like that, I just did it as a symbol. Like that's the symbol you want us to use, like the numerical value of 5.
Right. Symbols all right. If it doesn't ask you to do numerically, then you have to actually do that with the symbol in the website. You're correct, and I should have put in here. Compute it down to 4 decimal places or things like that. So, but keeping the pi in it is a correct answer. Yes.
When you divided the 8,000 by 2 pi,
Uh-huh.
when you divided...
Go ahead. I'm just saying yes. Yeah.
Okay, sorry. So when you did that, why did you keep the 8,000 in the left-hand column?
All right. So this is This is a one equation, right? That's the same equation, and this semicolon part is like a preparation. I didn't change this equation. I'm doing this part to figure out what n is. So nothing happens to this equation, right? I'm just doing that to figure out what n is, a shortcut. So in relationship between this and that is not that I'm dividing both sides by 2 pi or anything like that. I'm keeping this equation exactly it is and just figure out what n is, a very shortcut method. Before I showed you all the manipulation. You were thinking, oh, why is it not manipulating? Then isn't that 8,000 supposed to be divided by 2 pi? He just divided it, right? But that's my answer. I'm just keeping this equation. This is where you want to return, and skipping all that intermediate calculation, and just do this calculation to get the answer for n quickly without manipulating this one. So I'm keeping it here and plug it back in there, and that's the cleanest way to do that. Yeah.
Will you explain the last part?
So once you get this number, n being 1273, where you return is this equation where the n is. This is where n is. We don't know alpha. So you plug in that number in here in place of n. Then this one shows up here. And that equation is exactly the same, except that n is replaced with 1273. So I plugged in n equals there, 1273.
When I put that in my calculator, it came out negative. It's still the 1.5051, but it's negative.
I can take a look at it later. I don't see why you have a negative in there. All right, but
8,000 negative.
yeah, probably that's why.
Okay.
Yeah, you here. I get rid of 8,000 negative. It's a positive 8,000. Yeah, it's true that a lot of things happen that subconsciously, the little thing that you do, not knowing whether it's correct or not, is very difficult to fix, but it's going to really harm your test grade. It's not a little mistake everywhere. You really have to, whenever you got the wrong answer, you really have to pin down what went wrong, right? It's very important. All right. Let's see. That's coterminal. I think I covered pretty much all these problems with different examples. If you're looking at this problem, having pi in that angle instead of like having 8,000 radian, the same thing, right? The pi is just a number you divide it, and it's the same thing. Do you think we should do this problem? Yeah, I think we should do this problem. I feel that one right now. Oh, let's do one more. All right. Exercise 3. Find the coterminal angle beta to 19 pi divided by 4. I think it's the same problem. Your alpha is at 19 pi divided by 4, and beta is in. So this, I hope this is a role of alpha beta changing is okay. I think it's a challenge. You can do it. I think the first challenging part is dividing that 19 pi over 4 by 2 pi. And I hope you realize that that's the same as multiplying reciprocal of 2 pi. So denominator together is 8 times pi, right? So in my calculator, I put parenthesis 8 pi in there. That, shortens your typing process a little bit. And then it turns out 2.375. So what's n is this 2 right next to it. That's the largest integer. So come back to this equation and plug in n equals 2 there and solve for beta. How about this role of beta switched around the same as before? I hope that's okay. Yeah. So if you do the arithmetic and its exact value is 3 pi over 4, this problem actually shows up in the Weber sign. They want 3 pi over 4, not 2.3561. Yes. It's just a letter calling x and y and z. It is about this smaller angle, right? We're looking for this beta is supposed to be smaller angle. The smaller angle went here, the larger angle to the left side. That's how we did it, right? Not because it's beta. It's not absolute letter that should go in here. Larger angle, whatever the angle in here, and the target angle goes there. That was the relationship. Angle is given here, and you figure out this one, right? That's the problem if you read it. Given angle is beta. That given angle is not beta. The given angle is 19 pi over 4, and you figure out that angle, which was called alpha before. So if you change that to alpha, that's just a dummy variable. So it's the same thing. Yes?
Why wouldn't it be 15 pi?
Oh yeah, 19 over 4 minus 4 is not 15 over 4, right? You know that.
But if it's 19 pi minus 4 pi, wouldn't it be 15 pi? Because it's just the denominator.
How about this one? 19 over 4 minus 4? Is that 15 over 4? It's not, right? You have to have a common denominator to combine a fraction. Yeah. 19 over 4 minus 4 is not 15 over 4. Yeah. Yes?
For the answer, how will we know if we need to leave it in a fractional or decimal form?
If it doesn't say anything, it has to be exact for WebAssign problem. If WebAssign wants this one, it'll say round to your answer to 4 decimal places. In my test, exact numerical is always specified. Any other question? So, pretend real quickly that this little example. Negative 8,000 degree and 278 degree coterminal to each other. That's a question. So rather just going back and forth, and that was correct. 180 degree, I'm sorry. Those who have a better memory than I do, remember that. Oh, I remember that. That was a coterminal, right? But suppose you lost that memory. How are you going to do it now? What's the best way to do about this one? So you are given a large angle and another small angle. They're asking if these two angles are coterminal to each other. 8,000 is challenging to actually do that one at a time. So best way is that, alright, here's in one answer. If they're coterminal to each other, what is supposed to be happening? These two things are not the same, but plus 360 times n must be involved in there, right? So let's see, if we solve for n must be turned out what kind of number? Integer. No fractions involved in there. So let's solve for, so is that okay if I move 360 over there and do that like this? Hope that's alright. So that number is negative 8,280. Right? So how do you solve for n? Divide that by 360. Now you punch in the calculator. What was the answer? Was it 22 something? 23. Flat 23. There was no 23 point anything. It's exactly 23, right? So is n an integer here as you solve it? Right, it's an integer. If I change that to 279, and if you divide that, you will end up at like 22 point something or 23 point something. Now you know n is not an integer. If it's a coterminal, that number n, worked out algebraically, must be an integer, right? Therefore, you can conclude it from there. Since n we worked out that 23 is an integer, we can conclude that negative 8,000 is coterminal to 280 degree. If a guy in the street asks you, is negative 8,000 degree coterminal to 280 degree, and you tell him this is how you answer, right? Okay? If these are two angle measured in radian, then the exactness loses a little bit because you have to divide by 2 pi. You are never sure that the calculator number you got is exactly equal to or not. Even though you've got 22.9999, maybe it's involved in an error, so it got a little bit trickier than that. But degree measure, it's usually involved with this type of number, so it's easier to determine. Okay?